Elizabeth. Thank you for the intro, and I'm from Meta. We build artificial intelligence in the service of science, and you can find us at meta.com. Let's start here, though. The scientific paper. How many of you have read a scientific peer-reviewed article in the last couple of years? From end to end? That's a pretty good representation. That's awesome. So the 26 million papers published in biomedical journals represent everything we know about biology, medicine, and healthcare today. Everything we know is in those 26 million papers. And your job as an analyst at a pharma company or as a scientific researcher focusing on cancer research or as a healthcare provider is to stay on top of what's going on in the field so that you can make a contribution to the scientific progress that we're making, or that you can make better business decisions for your company, or that you can go ahead and provide better healthcare to your patients. So what's the problem? In one word, the problem is scale. And in the few minutes I'm going to be up here today, 35 new papers are going to be published in biomed. And in the 10 minutes after that, in the next demo, another 35 papers are going to be published. You get the idea. Over 1 million papers are published every year, and the rate's just increasing. So at Meta, what we've done is we've built an AI specifically trained on understanding and predicting the future of science. And we use that AI in large part to drive meta.science, which you're seeing here. I apologize, it's a little washed out, but this is a free tool for researchers in order to stay on top of the research in their field and solve that very, very real problem of publication overload. So let's suppose I'm a genomics researcher, and I'm trying to get up to speed on. So some people are trying to ruin my demo too. This researcher is trying to get up to speed on Zika, a new emerging disease, in order to make sure that they know the latest that's going on. Very quickly, what I can do, I don't know why that dropped off. Very quickly, what I can do is I can search through the 62 million unique entities that make up all of biomedicine and zoom in on a very clear overview of what's going on specific to Zika. All the papers that have been published, all the top researchers, all the researchers, including the top researchers in this field, all the journals that this content is being published in. And at Meta, we also use the artificial intelligence in order to generate recommendations here. So I can zoom in, for example, and look at an individual researcher who's focused on this field and take a look at all of the papers he or she's published, all of the topics they published on, where they're getting published, and what kind of work that they do. And I can continue to drill in and explore the specific area. So I can go in and look, for example, at a specific technique or a procedure that's being used in the lab. What's going on there? What paper should I read if I need to understand how to use this technique? All the way down to, for example, an individual gene for an individual organism to a protein or even a molecule. All of that is in MetaScience and available for free for researchers. So within those couple of clicks, you can start to explore all of science. And what we've done here is at any stage you find something that's of interest to you or very related to your specific area, I can go ahead and add that to my feed as easy as it is to follow somebody on Twitter. And now what I have is a feed of papers being updated to the minute. You can see a few seconds ago a new paper was published and it matches my very specific area of research, so the gene I'm specifically focused on in breast cancer, for example. And I know instantly what I should be taking a look at, rather than just trying to surf through all of the journals out there with all of the regular content. So as a user, my top priority here is to never miss an important paper in my field of research. I need the peace of mind of knowing that I know everything that's going on in my specific area. So I can scroll through this list. You can see I have 151 new papers since the last time I've logged in. And I can scroll through that list. It keeps track of which ones I've viewed, which ones I've opened. If I find something like this paper that is of interest to me, I can go ahead and explore it further. I can take a look at the abstract, the full list of authors. I can download the full text. I can save it and organize it in one of my libraries, or I can go ahead and just simply star that to remind me to take a look at it later. And by the time I've scrolled through this whole list and picked out the ones that are of interest to me, I know and I have the peace of mind that I'm up to date on my research, so I'm going to mark everything as viewed in here. And that's just the tip of the iceberg, though. Really, what I also need to do is keep an eye out on the broader areas of research related to my field. But say for a broad field like infectious diseases, there's no way I'm going to be able to read every single paper in this category or these set of categories that are important for me to follow. And this is really where Meta's predictive AI starts to come into play for meta science. You can see just following tropical diseases, tropical infectious diseases, over 4,000 papers have been published in the last couple of months. I certainly don't have time to even skim through that list, never mind read that list. So what we've done at Meta is we've gone ahead and we've used predictions in order to make sure that you know what are the top couple of papers to read, even if you've only got a couple of minutes. So I think most folks know, but ever since the first scientific paper was published, papers have been ranked by order, in order based on the impact, based on the number of citations that each paper has, right? But of course, the first paper, when a brand new paper is published, it has no citations. It might even take up to 2 years for a new paper to get a citation, just because that's how long it takes for science to happen. So what we've done is we look, using our machine learning algorithm, we look at over 200 unique characteristics in every single paper the moment it's published. And we use that and we generate a prediction of how much impact this paper is going to have 3 years down the road. We're currently looking at a 3-year window. So this list of most impactful are the top most impactful predicted impact papers for 2019. So if I'm going to look at these, any papers, I'm going to go ahead and I'm just going to star the top couple I can look at, and take a look and read those later. That is a very quick overview of just the tip of the iceberg of meta science, but I'm looking forward to your questions. Thank you.
Hi, thank you. I wish I had that way back when.
Yes.
You talked at the end about your algorithm. Can you give a bit of detail how it works? Because when I was doing research, it was all about buzzwords. And I'm just trying to figure out how your machine learning does, if it's just looking for the most, is the top one the one with all the buzzwords, in a row, and it's like, oh, it's going to have a huge impact. How do you actually measure that? Thanks.
Sure. So I'm happy to take the conversation offline if you want to go deeper. But at the highest level, what we've done is we've trained the machine to take a look at papers from history and figured out what's going to lead to a big impact today. So those over 210 characteristics we're looking at, it's who's authored it, what institutes are they at, who have they co-authored with. We're taking a look at not just the number of citations, the content of the paper, but also the quality of the citations. Are they coming from other areas of the network that are highly ranked as well? We do look at the language within the paper, but that's only just one of many characteristics that sort of come to derive this predictive score.
Hi, quick question. So you mentioned the predictive capabilities of your AI.
Yes.
Have you been able to backtest that predictive capability, and what sorts of results have you seen in backtesting?
Yeah, that's a great question. So a lot of the stuff we've needed to do working in AI over the last 5 years has proved to people that this actually works, because I can show you a bunch of predictions for 2019, and I'm not going to get in trouble for a while. But what we've done is we partnered with Elsevier, which is one of the largest publisher out there. We took a look at 1.1 million different manuscripts and published papers with them in history, and we went ahead and we predicted that into the future in a blind test. So we've done a number of that kind of stuff. It started there, but that's really where we started to get the first set of great results, and now we're just continuously refining and tweaking how good the algorithm is.
Are you providing the papers for free, or are you able to, because how are you able to do that when all the journals require a subscription?
Yeah, so we don't provide papers, closed access papers for free, but if you log in with your university credentials or your work credentials, 95% of the time we can resolve it and send you straight to the full text. We're also doing integrations into the more and more common paper rental services and that kind of stuff as well. So if you're interested in this paper, you don't get access to it through your school or through your work, then you'll be able to rent it. Not directly from us, we just sort of pass it along. Of course, if it's open text, open access, then we'll pass you straight to the paper.
Can you tell me about your revenue model, how that works, and also who can get access? So it's one thing if I'm working within a pharma company, for example. It's another thing if I'm an academic researcher, medical researcher. In my case, I often work on behalf of one or the other of those clients. So I
Yep.
can see this could be something really valuable for me.
That's
And I'm
right.
sort of wondering, is it something I could access and how and who's paying?
Everybody here can access this for free. Actually, one of the things I wanted to introduce you, even if you're just a science enthusiast like me, feel free to sign in and subscribe to all the different topics that you might personally suffer from. So you probably get an idea over here, and you can stay on top of the research yourself. But the underlying AI that we use, where we also have a commercial side of the business, where we're using those predictions and more in order to be able to have pharmaceutical companies, publishers, and authors looking to get published take access to the data. But this is free and will always be free.
Thanks. So I'm a researcher, and I have a built-up library. Say, I personally use Mendeley, but say any other sort of library software.
Yep.
And if I were to import some of the libraries that I've built up into Meta, what sort of intelligence or analytics can I derive out of my library, and what would I see
Yep.
as an end user?
You are my favorite kind of user because you have a library of content, and to onboard you and get access to content that's specifically useful for you is as easy as a couple of clicks. So we're going to be releasing an integration into systems like Mendeley, probably Papers, and a couple others shortly, and that basically helps instantly build what enough we need to know about you in order to generate other recommendations and predictions. If you don't have that, don't get scared. There's a little bit of an onboarding process where you can tell us either what lab you work in or what kind of things you're interested in, and over time we'll build up and give you more and more recommendations. But if you've started with a library, you're already off to the races.
Hi. I just have a quick question. You say you predict. So is there some sort of predictive modeling that you use?
Yes.
Okay.
Yeah, absolutely. That's a big part of what we do. We've built a lot of it ourselves. We're also the sole commercialization partner for $65 million worth of research that the US government has sponsored in order to help people understand what's happening in the future of science. So that's only partially reflected in here. It's going to be in a lot of the commercial products as well. But that's the tip of the iceberg when it starts to predictions, what you can actually do. Great. Thanks, guys.